Well, now we're going to talk about how energy systems are producing the electricity that we use and the differences between some fossil fuel generated electricity sources and low carbon energy systems. And so we're going to assess where the sources, current sources of our electricity are, what carbon dioxide emissions are associated with those, what are the advantages and disadvantages of some of those systems. And then in the next lecture, we're going to look at the possibilities of energy sources for the future. So let's look at what we need to consider in terms of current energy sources and how we make choices between those. And it's critical and important, as we talked about in the last lecture, about providing electricity for development, to alleviate poverty, to power society. And it has to be at a price, at a cost that people can afford. And that's probably somewhere between 10 and 20 cents per kilowatt hour in current day dollars. It's not going to be possible to have electricity and energy available for development and for reduction of poverty unless it's available at the cheapest available price. Now, the problem is that to reduce consumption, people argue that we have to put the price up. But if we put the price up to discourage consumption, that also puts pressure on poor people and on development. So we're in a dilemma. We want consumption of electricity to go down. The only way that we can reduce emissions is by switching to low or zero carbon energy sources. Another critical factor is population. And what we have to be able to do is, there's always this point of view. There's only one of me, what can I do in terms of changing emissions? Well, actually, when you add up the large number of people, such as in Australia, more than 22 million people, that's a tiny fraction of the world's population. It's only around 0.3% of the world's population. But actually, Australia makes more than 1.3% of global carbon dioxide emissions. In other words, Australians are having a disproportionately high contribution because our energy sources are very inefficient and high in carbon dioxide. So we've got to look at the different sources of energy and what that emissions are. One of the questions is, well, if we set a price on something, maybe the free market will determine. But actually there's been no cost put on emitting carbon dioxide into the atmosphere. And so market schemes, by putting a price on the carbon dioxide emissions, is going to be addressed much more in the economic discussion as part of this subject. So let's look at how electricity is used and how it varies from day to day. And we talk about two different types and two different sources of electricity. We need base load power for industry, we need base load power for transportation, but then we also need peak electricity. And peak load electricity is what's needed for the daytime peaks when there's travel to work or there's lights going on or heating during the daytime, but it's also needed for air conditioners on very hot days or lots of heating on very cold days. And so there's a daily cycle in electricity use, as well as much greater peaks on very hot days or on very cold days. Typically the sources of peak electricity would be from renewable sources. On a very hot day, you could generate electricity from solar power, but there's also peak electricity driven from fossil fuels by gas generated, and baseload electricity comes from either hydropower, from fossil fuel generated electricity, and also it can be generated, as in France, by nuclear reactors from fission sources of electricity. Now here's some graphs that show the peak demand for electricity in both summer and in winter, and we see this is a typical daily cycle in summer. And in summer, late in the afternoon, there's often a peak in electricity use associated with the need for air conditioning to cool down cool down homes and cool down buildings on very hot days, and that's typically in the afternoon. Whereas in winter, here on a typical day, yes, there's peak load, but it's typically more spread out on the daytime. And in both these cases, the minimum use is overnight or early in the morning, when people are sleeping, when industries aren't operating as much, but there is still a base load power, and this is because there are many activities, particularly industrial activities, that continue throughout the day. Here's another example. This is examples of the diurnal cycle, the day-to-day cycle of electricity use in Germany. And now we can see in these different colours the sources of the energy that is used to generate that electricity. And the base load power is being driven by fossil fuel sources primarily, but the peaks are being driven by a range of other sources, including particularly solar power and wind power. And you can see that solar power and wind power can make a major contribution to the peak load in a range of countries, and they provide important characteristics for the flexibility, but of course that's one of the limitations of solar power. Unless there's long-term storage, we can't use solar power except when the sun is shining. And we're going to talk about that in just a few minutes. So in terms of the overall global sources of electricity power, the vast majority of it is coming from coal use, as well as from oil and gas. Nuclear is providing about 13% of electricity, and if we then think about the low carbon sources, it's really only this sector from nuclear around to the renewables. Only just over a quarter of the global electricity use is generated from low carbon energy sources. If we think about completely renewable energy sources, it's the hydro, the solar and the wind power. And we're going to look at those as a contribution in just a second. But in particular, given the current energy use and the projected increase in energy use for development, for alleviation of poverty, and as we each want more computers and more phones and more electric gadgets, there's expected to be a major growth in global electricity use over the next 50 years. So, if we're to turn around our global emissions of carbon dioxide, we need to find a whole range of possible energy sources which can produce energy without as much carbon dioxide emissions. So we need the power, but we want to do it without carbon dioxide. And so there isn't a single solution. We have to look at a combination of solutions. And what we really have to do is first of all stabilize and then reduce these emissions. And what we use is something called a wedges approach. A wedge is the amount of reduction in carbon dioxide emissions that can be produced or obtained by a different energy source. So let's look first of all what would have been greenhouse gas emissions if we'd waited until 2050. But that then means much higher emissions and then would lead to much higher carbon dioxide concentrations in the atmosphere. Where we want to be to is to turn around emissions and then have them reducing. We'd even like that reduction to occur much faster. It really needs to turn around by 2020. So one of the options is to switch from fossil fuel electricity driven by coal or oil to lower carbon dioxide emission sources. And some of that could be natural gas or other carbon capture and storage solution which captures some of the carbon dioxide. And then there are zero carbon dioxide energy sources. And carbon capture and storage is one option, but then completely renewable sources like solar power or like wind power, or increases in hydroelectric. Now, there's not much scope for increasing the production of electricity from hydroelectric schemes, but there's enormous scope for electricity generation from solar power, from wind power, from geothermal, from a range of different sources around the world. Unfortunately, there's a gap, and that gap between what is currently available from these low carbon energy sources has to be filled by dramatic improvements in energy efficiency. Doing what we want to do much more efficiently. In other words, having more efficient low energy use, more efficient cars, more efficient transport, more efficient buildings in terms of requiring less heating and cooling, more efficient industrial processes. All of those can lead to marked reductions in energy use and therefore marked reductions in carbon dioxide emissions. And energy efficiency can be done at what's called negative cost. If you reduce your energy use, you will save money. And so there's no reason why we don't dramatically improve our energy use and save money at the same time. Using a more energy efficient car means a car that uses less petrol. Using a more energy efficient refrigerator or air conditioner means you save money in the long term. Unfortunately, there may be some relatively bad contributions from these low CO2 energy sources, like using natural gas, and we're going to have to remove those as well. And also, we have to start to turn around to actually reduce emissions. We can't just stabilise them, they actually have to keep on falling. And so just using those wedges, we have to continue our improvement and our increasing use of zero carbon energy sources. So let's look at some of these different power sources and the opportunities, the pluses and the minuses. Well, this is a conventional coal-fired power station. It uses the heat generated from burning fossil fuels, particularly coal, to generate steam, and that steam is then used to turn a turbine, which generates electricity. And it's more efficient the hotter the turbine is. The pluses are that it's cheap fuel. Coal's very inexpensive, it's an established technology, and it works very well for baseload. And the biggest problem is the carbon dioxide emissions. There are also other pollutants, air pollutants, particles, mercury in the emissions, and it needs a lot of water. It needs water to cool down the power station as well. So the biggest problem with conventional thermal power stations is they produce carbon dioxide emissions, and those carbon dioxide emissions are because of the use of coal. The only way you can reduce emissions from this sort of a power plant is using what's called carbon capture and storage, where the emissions are trapped in the chimneys of the power plant, but that technology does not exist in commercial and large-scale systems at present. So, another existing technology with zero carbon energy use or zero carbon energy production is hydroelectric. Basically, trap water behind a dam and then run the water through a pipe. It flows past a turbine, and that turbine then generates electricity. The advantage is that there's essentially no greenhouse gas emissions. There's no fuel that's required, but it does need water. And so water and land are actually very valuable commodities for a range of other uses, for agriculture, for human water resources. The limitations of water, particularly in times of drought, are substantial. The other big advantage of hydroelectric power is that it's very useful for peak load. It can be switched on and switched off very quickly. There are a number of other energy sources, and so wind power, wind turbines have been growing in use around the world, and they're now dramatically contributing to the increase in energy supply around the world in many, many countries, particularly developed countries in Europe, but there's also major increases in wind turbine use in North America, in Australia, and in many, many countries around the world. There are limitations because it's a variable energy source. and it doesn't generate high densities of electricity, and it can't be stored in that system itself. Once it's generated, it can't be stored. You can't turn it on and turn it off. You can only generate electricity when the wind is blowing. But if you have a network of these wind turbines across a large area, while the wind mightn't be blowing in one area, it will almost certainly be blowing in another area of the country. So networked wind power can be a solution. If we look at the range of different possibilities and the current supplies, we see that in terms of carbon dioxide emissions per gigawatt hour of electricity, the worst is brown coal, and here in the state of Victoria, where Melbourne is located, we have electricity generated by brown coal, and that's part of the reason why Australian emissions are so high. The carbon dioxide emissions from black coal are almost as high, and then from oil, they're substantially lower from natural gas, and that's why natural gas is a lower carbon electricity source. Then we can look at emissions from low carbon sources and renewable sources like solar, like biomass, like wind, and like nuclear. But obviously there are issues with waste disposal for nuclear sources as well. And we're going to talk a little bit more about that when we talk about future energy sources in the next lecture. So to summarise, about 40% of current global electric power comes from fossil fuels. And if we're going to reduce that, we need a combination of different low carbon or low carbon dioxide energy sources to provide the growth in electricity and then to reduce the CO2 emissions. And we need a combination. There's no single solution. There's very little time available to develop new technologies that are going to solve this problem. We have to use existing technologies, and we have to implement them very quickly if we're to avoid dangerous human-caused climate change.